All right, guys, we're on number 3 here. Okay, so let's see. I've got f of x equals the product of 4x squared minus 25 times 16 minus x squared. Okay, so let's see, a couple things I could do. I'm just gonna go the product rule. Okay, so dy dx to get my derivative. Okay, so if we go here, okay, product rule. Notice it's the first times the derivative of the second plus the second times the derivative of the first. Okay, so I can apply that product rule. Okay, and so I go the first times the derivative of the second. Okay, so it would be 4x squared minus 25x times the derivative of this guy. Okay, d dx of 16 minus x squared plus the second 16 minus x squared times the derivative of the first 4x squared minus 25. Okay, so let's see, I would have my 4x squared minus 25 times, well, let's see, when I take the derivative of 16, I get 0. When I take the derivative of negative x squared, I get negative 2x to the first, or just negative 2x, plus, bring down this 16 minus x squared. Now, when I take the derivative of 4x squared, I get 8x to the first, which is just 8x. And when I take the square root, take the derivative of negative 25, I get 0. So the derivative of this guy would be 8x. And then we just simplify. So distribute over here. So I'm going to get a negative 8x cubed plus 50x. And then distribute here. So 8 times 16, okay? All right, 8 times 16, okay, 128. So I get 128x minus 8x cubed. And then we just collect similar terms. So it looks like I'm going to get a negative 16x cubed, okay, plus 178x. Okay, so I have my derivative. Okay, now that's not the only way to do it. Okay, we could go this route. This is not what I would do, but you could go this route. Notice that I could multiply these two binomials together using the FOIL method, and then just take the derivative of each term individually like we did up here in 1 and 2. Okay, so if I take that, f of x becomes, well, let's see, 4x squared times 16, that'd be 64x squared. Okay, 4x squared times negative x squared would give me negative 4x to the fourth. Right there. And my inside, 25 times 16, I'm pretty sure that's 400, but let me make sure. 25 times 16, that's 400, so I get negative 400, okay? And then negative 25 times negative x squared would give me a positive 50x squared. Okay, so if I just take the derivative straight through, so f prime or dy dx, it just depends on what you want to do. Okay, so let's see, this gives me 128 by going 2 times 64, x to the first, minus 4 times 4 is 16, x to the bx cubed. Okay, this is 0 when I take the derivative because it's a constant. And then we have right here, this would 2 times 50 is 100, x to the first. Okay, so we're in good shape there, and let me see. Okay, do I get a problem here? Okay, because I'm getting something different here. I'm getting a negative 16x cubed. This would be plus 228x, and obviously I get a mistake somewhere. Okay, so let's go back up here. Let's check the first one. So we go the first times derivative of the second plus the second times derivative of the first, so that's good. So this, we know the derivative here is negative 2x, right? This guy, the derivative here is 8x, okay. All right, so this gives me negative 8x cubed plus 50x, okay. 8 times 16, let's make sure we got that right. 8 times 16, I have 128x minus 8x cubed, okay. So far so good, so let's see, where did I make a mistake at? Okay, let's go back up here. Maybe I made a mistake when I used the FOIL method. So 4x squared times 16 is 64x squared, okay. Outside would give me negative 4x to the fourth, good. Inside, okay, let's make sure I got that. 25 times 16, okay, 400, good. And then, there we go, right there. Negative 25 times negative x squared. Okay, that'd be a positive 25 x squared. I had 50 for some reason. Okay, so when I take the derivative here, 2 times 25 is 50. Okay, and then when I add them, there you go. There's your 178x. Okay, all right. I knew I had a mistake somewhere. I have to get the same thing. Okay, so there we go. All right, so you got this guy and you got this guy, okay? So you're gonna get the same thing there, okay? It's just a matter of, you know, which way you wanna do it. Me personally, I would probably work with the product rule up here, okay? For whatever reason, I don't know. I just, you know, don't feel like doing the FOIL method and then take it one at a time, so I just use the product rule. Okay, so let's see. This next guy right here. All right, so let's see, we've got 4. Okay, so it's f of x equals, okay, I've got the trinomial x squared plus 2x minus 35 times 2 binomials, 2x plus 3 times x minus 4. Now the problem we run into is we don't have a product rule when you're multiplying 3 things together, okay, only for 2. Okay, so you got to multiply 2 of them together. Okay, so we could either multiply this trinomial times that binomial, okay, and get one polynomial, and so I'd have a polynomial times x minus 4. I could even multiply this trinomial times x minus 4 and get a polynomial times 2x plus 3. Okay, but it's going to be so much easier to multiply these two guys together. Okay, and just get a trinomial, so I'd have a trinomial times a trinomial. Okay, so let's see, we've got x squared plus 2x minus 35. And let's see, when I multiply these guys together, I'm going to get 2x squared. Okay, let's see, outside will give me negative 8, inside gives me 3. So negative 8 plus 3 is negative 5, so negative 5x, and then 3 times negative 4 is negative 12. Okay, now, going back here, the second way we did this, we multiplied everything together and then just took the terms one at a time. Okay, clearly you could do this here, but notice it's going to take a lot more work because I'm going to have to use triple distribution and then simplify and then take the derivative one term at a time, and I just don't feel like doing that work. There's no reason. Okay, so when I do my dy dx, I'm going to take the first times the derivative of the second, so it's going to be x squared plus 2x minus 35 times the derivative of the second one, 2x squared minus 5x minus 12, okay, plus the second, 2x squared minus 5x minus 12 times the derivative of the first, x squared plus 2x minus 35. Okay, and so let's see what happens here. Okay, so I get the first x squared plus 2x minus 35 times the derivative here. So the 2 comes out front, I get 4x to the first, or just 4x. Okay, then take the derivative of negative 5x, okay, so I just get negative 5. And then take the derivative of negative 12, I get 0, so it goes away. Okay, plus this guy, 2x squared minus 5x minus 12 times the derivative of this guy. So the derivative of x squared is just 2x. And the derivative of 2x is 2. And the derivative of negative 35 is 0. Okay, so I've got to simplify that. Okay, so let's see. I'm going to do double distribution. I'm going to distribute the 4 and then distribute the negative 5. Okay, so let's see. When I distribute the 4, I'm going to get 4x cubed plus, that'll give me 8x squared, okay, minus 4 times 35 is 140, so I get 140x, okay. Then I distribute the negative 5, so I get a negative 5x squared minus 10x plus 5 times 35. Let's see, 5 times 35, 175. Okay, and then I gotta go plus this guy. I'm gonna do the same thing. I'm gonna distribute 2x. So I'm gonna get 4x cubed. Okay, let's see, 2x here, that's gonna give me a negative 10x squared. And do the same thing here, 2x times negative 12 is negative 24x. And then distribute this 2, so I get 4x squared minus 10x, okay, minus 24. And then we just gotta collect similar terms. So let's see. I've got a 4x cubed and a 4x cubed. Okay, that's 8x cubed. Okay, I've got an 8x squared, a negative 5x squared, a negative 10x squared, and a 4x squared. So let's see. That'll give me 12x squared minus 15. So 12 minus 15, negative 3. So negative 3x squared. Okay, let's make sure I got that one. 8 minus 5 is 3. Okay, 3 minus 10 is negative 7. Plus 4 is negative 3. Okay, and let's see. I've got a negative 140, a negative 10x, a negative 24, and a negative 10x. Okay, so let's see. Got negative 140 minus 10 minus 24 minus another 10. I'm getting negative 184x. 84x. Okay, let's make sure we got that. This gives me negative 150. Negative 174, negative 184. Yeah, okay, we're good. And then lastly, I've got the 175, okay, minus 24. So that's going to be plus 151. Okay, I got my answer. All right, that's how I would attack it, okay? I think that's the easiest way to do it because obviously, you know, if you get here, technically, could you use triple distribution and get this long, okay, polynomial and then take the derivative one step at a time or one term at a time? You could do that, and obviously it'll give you the same exact answer.